So I want to start this afternoon session. We are going to open with Tirhas from Ethiopia. She's going to talk about the prevalence of iodine deficiency disorder on mothers and infants in Ethiopia. So please, Tirhas.
Thank you, Betty. Good afternoon, everyone. My name is Tirhas Mebratu. I am from Ethiopia. My research exercise topic is on prevalence of iodine deficiency disorder in mothers and children in Ethiopia. This work was done under the supervision of Dr. Aaron, and also I would like to pass my special thanks for my donors, Moorberg Foundation and Ms. Isabel Adler. Start with the introduction. Iodine is an essential micronutrient which is a major component of the thyroid hormones T3 and T4. Those two hormones are very important and necessary for normal growth, development, and metabolism during pregnancy, infancy, and throughout life. Naturally, iodine exists as a form of iodide in soil and seawater. However, it's changed into, or it's converted into iodine when it's exposed to sunlight, and this affects the content of iodine in plant and animal source of foods. Therefore, due to this reason, it leads to variation of daily iodine intake from food compositions throughout the world, and also it leads to intake of iodine below the required amount. Therefore, when we take iodine below the required amount, it leads to iodine deficiency problem, and those different problems which are caused because of iodine deficiency are collectively called iodine deficiency disorders. Iodine deficiency disorders are a major problems in the world in different developmental stages, especially during pregnancy and infancy. Iodine deficiency disorders have different health outcomes, some of them like high perinatal mortality, and as we know, cretinism, development of goiter, infant mortality, miscarriage, or stillbirth are some of the health outcomes of IDD. When we take a look what it looks like worldwide, the iodine deficiency disorder, this map is a national iodine status based on median urinary iodine concentration in school-age children in 2011. So countries which are indicated in the darker purple are those countries which had a moderate iodine deficiency, and countries which are indicated in lighter purple, light purple color are indicated mild iodine deficiency problem. So as we have seen from this map, iodine deficiency is not only the problem of developing country, however, it's also the problem and challenge of developed countries also. And according to the International Council for Control of Iodine Deficiency Disorder 2012 report, iodine deficiency will remain a major health problem in about 32 countries. So among those countries, my country, Ethiopia, is one of the top iodine deficient countries. To say a few things about Ethiopia, the country is divided into 9 regional states and 2 administrative cities, and some part of the country is highland and some part of the country is covered with lowland altitude. So the distribution of the prevalence of iodine deficiency from one region to one region is also different. Populations mostly which are living in the highland part of the country are more prevalent for iodine deficiency, because in those areas there is soil erosion and leaching of iodine from the topsoil. This problem leads to the deficiency of iodine. Previously, several reports showed different statistics about the different iodine deficiency disorders in Ethiopia, but from a recent report, according to the International Council for Control of Iodine Deficiency in 2011, about 12 million school-age children are living with inadequate iodine, and also 66 million people are subject to the risk of iodine deficiency disorder in the country. There could be several factors which can contribute for the development of IDD in Ethiopia, but I would like to mention some of them. The first thing is a lack of awareness about the importance of iodine. As I know, in Ethiopia, the awareness about iodine or the know-how about iodine in the country is low, because the concept is the emphasis which were given for this micronutrient is lower until recent years. And the second thing could be inadequate access to iodized salt in household. A strategy which is called universal salt iodization is a new strategy in Ethiopia. Therefore, before the country was trying to import the iodized salt, so the distribution of this iodized salt throughout the country and throughout all regions were not well good. And the third thing could be iodine deficient soil in the country, as I have mentioned earlier. Especially populations who are living in the highland areas are more prevalent for iodine deficiency because of the soil which is iodine deficient. Therefore, the objective of this review was to summarize the existing literatures on iodine status in Ethiopia in light of the emerging question of iodine requirements during pregnancy and infancy. As a methodology, this review was a systematic review. So this review was a systematic review. So I tried to search studies from PubMed and Google Scholar by including some of those and additional other key pointers. Then I have got 25 studies. From those, I tried to screen and record the suitable studies. And some of the articles were excluded, and because they didn't fulfill the criteria of full text studies which were conducted since 2000 up to date, and specifically which are not done in Ethiopia were excluded from among the studies. Then I tried to assess the full text of the screened articles. Then finally, 15 articles were eligible for reviewing the final review. When I come to the result and discussion, before I went to describe about the findings, I would like to just show you the highlight about the different studies that I have got. The studies were done as a national and regional level. So almost most of them did as a regional level, and few of them did as a national level. And the major outcome of the studies were goiter rate and urinary iodine concentration, but few studies tried to see cognitive function on children's, thyroid stimulating hormone level, and also tried to assess level of iodine in salt samples. When I start discussing about the findings, I'll start with prevalence of iodine deficiency in Ethiopian women. Even though iodine deficiency disorder affects a large proportion of Ethiopian population for a long period of time, very few scientific studies have been carried out, especially on women as a national level so far. So among the few studies which were done on women were a survey which was conducted in 2007. So in this study, they tried to assess the goiter rate of women who are found at the age of childbearing. So in this case, they found a result that the total goiter rate was above 30% in 4 regions. This a national survey. So among the 9 regions, in 4 regions, it was found above 30%, but it was found up to 60% in the southern part of the country. And the remaining regional states had goiter prevalence ranging from 5 to 29.9%, with the exception of only one region which is found in a normal range, which is below. The goiter prevalence rate was 1.4%. That means it was below 5%. 5% is the cutoff point for goiter prevalence in a population. In addition to this, in this study, they tried to see the association between pregnancy outcomes and intensity of goiter. So as a national level, the pregnancy outcomes like stillbirth and miscarriage were 35.5% from the high endemic region, and it was 11.2% from the less endemic region. Additionally, another study, which is a very recent study done specifically in the southern part of the country only, they tried to assess urinary iodine concentration and total goiter rate on women who are living in the rural part of the state. So according to the urinary iodine concentration, 46.5% of the women had a moderate iodine deficiency, and 22.8% had a severe iodine deficiency. And among all the participants, only 3.5% of the women had an adequate iodine concentration. Additionally, from the same study, the total goiter rate among the participants was generally 50.9%. 1.5% of the women had a visible goiter, and 40.4% of the women had a palpable goiter. So as we have seen from the national survey study and from this study, the southern part of the country is severely affected by iodine deficiency. This could be due to several factors. Maybe it could be dietary factors or environmental factors. When we say dietary factors, there are food sources which aggravate iodine deficiency by limiting the uptake of iodine by thyroid gland. Therefore, those are called goitrogenic factor. So some examples of goitrogenic factors are like cassava, moringa, cruciferous vegetables are some of the examples. Therefore, cassava is the most staple food in the southern part of the country. So in my opinion, for the increment of iodine deficiency or the total goiter prevalence in the area could be, the reason could be consumption of cassava. To support my idea, there was a study done in 2008 in the southern part and other neighboring regional states. So in that case, they tried to assess the association between cassava consumption and goiter rate. So finally, they have got that. Consumption of cassava had a direct association with the development of goiter. When we see the prevalence of iodine deficiency on school-age children, again, this is a survey, a nationwide survey, and in this survey they try to see urinary iodine concentration and total goiter rate among children. So according to the urinary iodine concentration, 46% of the children had a severe iodine deficiency, and only, it's a national study, so among those, only 70% of the children had an adequate iodine concentration, or well, they were found in a normal stage. This is from the same study, and they tried to show the total goiter the prevalence of goiter in the different regional states. So as we can see from this graph, the total goiter rate was higher in the southern nations. The percentage of total goiter rate was higher in the southern nations. Then it was followed by the Oromia region, Benishangul Gumuz, and finally the lowest percentage of total goiter rate was found in Harari region, which is found in the western Ethiopia. So this variation of prevalence of goiter among region to region indicates that, as I mentioned earlier, it could be the dietary factor or environmental factor. For example, Dredwa and Harari region are found in a lowland area of the country, and in addition to that, cassava is not common on those areas. The dietary habit in those areas and in the southern part is also different. So this could be the main contributor for the variation among the different regions. Additionally, a research done in this northwestern Ethiopia, it showed a similar trend in the urinary iodine concentration and total goiter rate prevalence. But in this study, they also tried to assess thyroid stimulating hormone. So 80.92% of the children had an elevated thyroid stimulating hormone. That means they had a hypothyroidism. And 27% of the children had a suppressed thyroid stimulating hormones. That means a hyperthyroidism. Hyperthyroidism, most of the time, it's caused because of it's due to high intake of iodine. So this study is a very recent study, and in Ethiopia, salt iodization started in 2010. So it could be the reason for the increment of iodine intake or the hypothyroidism in the children. Another study which tries to assess the cognitive function of children were done in 2013. Again, this is from the southern part of the country. And in this case, they try to assess school children, so they have got that goiter has a significant impact on absenteeism and for poor academic achievement. And finally, they conclude that children who had goiter were 1.8 times more likely to have low academic achievement than those who didn't have the problem. Okay, when we talk about the intervention, iodine deficiency disorder are considered as the most important preventable cause of damage, and universal salt iodization is the most preferred one to eradicate this problem. So when we see the history of salt iodization in Ethiopia, it was started actually in 1989. However, it was interrupted due to the conflict between Ethiopia and Eritrea. Then the government of Ethiopia in 2009-10 starts to revitalize and launched universal salt initiatives in the country. However, still now, me personally, I couldn't get enough information what it looks like the progress of this program. It doesn't show how much of the population is getting the iodide salt, how much of the regional states are covered by universal salt iodization. So there is a limitation of work, or there is no any study which can show the progress of this program. After the implementation, the only study which were done on salt iodization it shows the level of salt concentration at different stages at the production, retailer, and household levels. Actually, the level of iodine concentration on all of the levels were good because it was more than the minimum required amount, which is 20 milligram per kilogram. However, when we see the trend, it was decreasing from the production until it reached to the household level. For example, from the producer until the retailer, it was decreased by 27%, and from the retailer to the household, it decreased by 50%, and generally from the production side until it reached to the consumer level, decreased by 57%. This indicates that further work needs to be done to see the transportation way of handling and distribution, and in order to achieve the program, and also in order to eliminate the problem of iodine deficiency in the country. So before that, I would like to mention some points which I have seen during the review. The first thing is almost all of the studies were using a cross-sectional study. Actually, cross-sectional study is good because it's very cheap and easy. However, it's very susceptible for bias and different confounders, and also it's difficult to identify, to interpret associations. And the second thing is most of the studies use urinary iodine concentration and goiter rate as an indicator for the prevalence of goiter rate in the country. I mean the prevalence of iodine deficiency in the country. But those indicators doesn't provide a direct information about thyroid function. And the other point is almost most of the studies, especially on women, are from the southern part of the country. So this is difficult to say something about the iodine deficiency problem of Ethiopia because it's only from some regional, it's specifically from one regional state, so it doesn't represent the other regional states. And points that I would like to recommend for futures are a prospective cohort studies should be conducted to get an accurate association between the prevalence of iodine deficiency in the country and to reduce other confounders and to reduce bias. In addition to the urinary iodine concentration and goiter rates, thyroid stimulating hormone and blood thyroglobulin should be used to improve study validity. Priority studies must be given for pregnant and infants. Since this is the most critical stage, so more emphasis must be given for those target groups. And the fourth thing is examination of outcomes like cognitive function, language, and fine motor function should be done on children and mothers. In conclusion, iodine deficiency disorder is a major public health problem in almost all parts of Ethiopia. So application of universal salt iodization with adequate supply and regular monitoring would be useful at different levels. By implementing successfully these recommendations, the country can show the way to other nations how to eradicate the problem of iodine deficiency, especially on the most vulnerable groups, women and children. Thank you.
Thank you very much, Tirhas. And we are now open for discussion.
Congratulations, Tirhas, for your presentation. You showed us a graph that it said that from the moment that the producers made this iodized salt, until it get to the consumer, we're losing a lot. So can you suggest something that could be made in order to decrease these loss, or something that you think?
Okay, thank you, Phil. I think to reduce this problem, the first thing is it's appropriate handling. That means if from the start, starting from the production side, if the salt is packed in a very well material, at least it can reduce the problem of reduction of the iodine from the salt. And the other thing is the way of transportation. It's produced locally, so most of the time the way of transportation is in a local way. That means it's not appropriate way of transportation. Therefore, appropriate packaging, appropriate transportation, and appropriate handling could be a good thing to reduce this problem.
Hi, Tirhas. Thank you so much. My question is, given that I think it was a southern mountainous region that has the highest prevalence, correct? And you said one of the issues is that cassava is not in abundance there, I guess. Mm-hmm. Do you think education on the necessities of iodine would help at all with the locals in finding other sources, or is it really that it's so scarce of iodine sources that they would need outsourcing from other places?
Can you repeat it, Eva, please?
Sure. Okay, so if they don't have cassava, which is the main staple for iodine in the country, okay. Do you think if the locals were educated on, one, the importance of iodine in their diet, that there are other available foods that would help them, like instead of getting it from other areas, like in that region? Okay.
The first thing, the problem in cassava is the cyanide, which is found in cassava. So this cyanide can reduce through process by using fermentation and other processes. They can reduce by doing different processing stages. That's the first thing. The second thing is they have other options like cereal crops. They use cereal crops because cassava is recently introduced in that area. It's about 13 years in the area. It's not it's not known for a long time in that area. So the first thing they can use by processing the cassava. Otherwise, they can use other optional crops which are found in the area. They have other root and tuber crops and also cereals.
Okay, so sorry. So I guess in addition to that, is the problem then, if other crops exist for iodine efficiency, is the problem that they don't know about them?
Yeah, generally in Ethiopia, the population doesn't have that much knowledge about iodine,
okay.
As I know, because the emphasis by the government is also not given. It doesn't give a focus by the government itself. So.
Tirhas, a very nice talk, very informative. I don't know enough about agriculture, but maybe you can help me, or maybe someone in the room can help me. in Ethiopia, I'm assuming most people eat locally grown crops that they raise in their farms. Is there any way of doing fertilization for the replacing iodine into the ground so that when they eat the locally grown crops, they'll get it through the food chain and not have to give iodized salt or something like that? Is there a way to do that?
As my knowledge in iodization, generally it's a new concept about iodization in Ethiopia. But most of the time in agricultural production, it's known to use urea and DAP only in our countries, as I know. So for the future, maybe.
Does anyone know if that's a viable? Alan, do you know if it's a viable way to?
I don't think so.
You don't think so? That we can't replenish the?
I know there's research on that, and there are attempts to do that experimentally, but I know that it's not widespread and prevalent. So clearly, it hasn't reached a point where that's
An efficient way.
an efficient approach. But people have thought of that issue, and I'm not expert enough to answer what the state of the research is on using that in food production. One place that iodine is added into the food chain, the human food chain through agriculture, is by providing feed with iodized salt to cattle. Because milk is probably the dominant source of iodine from our food supply. And whether that has to do with the iodine that is excreted in cow's milk or due to the use of iodophores in sanitizing the cows and milk production lines during dairy practice is uncertain. It's probably the latter rather than the former. And it seems to be an important variable in population iodine intake.
Out the microphone. I don't know how they heard your answer, but there was a question from the internet that you want to ask, and next time you should have the mic. It's okay.
Okay, Prabhat, who I said before is viewing from the University of Copenhagen in Denmark, says this, just a response or question. First, in the developing world, I think we should focus not only on the fortification and supplementation of nutrients, but also we need to identify natural sources of iodine and create awareness among people. Hence, agriculture and nutrition really should work together, which was just what was just spoken about. Second, in Nepal, iodized salt has been very effective, and I was wondering why it has not been the same story in Ethiopia.
Okay, as I mentioned in my presentation, it was started in 1989 because during that time Ethiopia and Eritrea they were considered as like the same country, so Ethiopia was using iodized salt from the Red Sea. However, due to the war between those two countries, the Red Sea becomes under Eritrea, so Ethiopia doesn't have any source of salt to use. So since that time, it becomes like it's considered as a new strategy. It's because of the war between Eritrea and Ethiopia.
Okay, thank you.
Okay.
I think I have another question. Do pregnant women, do they have to be preoccupied of ingesting iodine that is provided by salts, or maybe they have to be happy to take it?
For pregnant women, actually iodine is recommended more than for normally women's. It needs about more than about 250 microgram per day. Mm-hmm. So if the pregnant woman can't get it from nutritional from food, it's recommended to take it by injection, because during that time it's very important for that woman. So.
Okay. Okay. Thank you very much. Okay. Now we are going to have Janerose, and she's going to talk about aflatoxin exposure and stunting in young children in Sub-Saharan Africa. This is Janerose.
Okay. Good afternoon, everyone. I'm Janerose Lusweti from Kenya, and my research exercise is on aflatoxin exposure and stunting in young children in Sub-Saharan Africa. This research exercise was supervised by my wonderful mentor, Dr. Aliza Stark, and I would also like to thank in a special way the PEARS Foundation. So, what is stunting? Stunting is a form of chronic malnutrition that is characterized by a short stature in nature. So, it's defined as a -2 standard deviation from the mean height for age Z-score according to the World Health Organization. Stunting is a public health concern, especially in developing countries, including Africa. As you can see in this graph, but in the recent years, the rates of stunting are going down, but as seen in Africa, which is represented by the red bars, it appears as if it's actually at a quite constant rate, and even in 2020, it's projected that the rates will be still at that rate, which will be only an increase by 0.7 units in the height for age Z-scores. Stunting has negative effects in the life of an individual generally. We see that stunted children have low developmental progress in their lives. They take a long time to acquire skills in life, and also the intelligence quotient is very low, leading to poor performance in school. And once someone does not perform well in school, it's very hard to land on a good career, and this will lead to low social economic status, which actually leads to poverty in the country. And also studies show that a stunted child, when they enter adulthood, they are likely to get central obesity and cardiovascular diseases, and this therefore increases the mortality and morbidity rates. What are aflatoxins? Aflatoxins are secondary metabolites of Aspergillus flavus and Aspergillus parasiticus. It's a fat-soluble toxin that can be detected in blood, breast milk, and urine. The serum levels are assessed as aflatoxin albumin adduct, and in breast milk it's aflatoxin M1, while in urine is aflatoxin guanine. These are the chemical structures of aflatoxin B1 and aflatoxin M1. Aflatoxin B1 is found in the plasma, while M1 is found in breast milk. There are actually different strains of aflatoxins, but today we'll focus majorly on these two, which are detected in children. Properties of aflatoxins: they are stable to heat. They are destroyed at a very high temperature of 268 to 269 degrees Celsius, and therefore we see that even most methods of cooking are not able to destroy aflatoxin. Furthermore, aflatoxin thrives well at a low water activity rate of 0.82. Therefore, it requires very little amount of moisture to thrive, and at the same time, it grows at 13 to 37 degrees Celsius. These are favorable temperatures even at room temperature. Therefore, aflatoxin can easily grow anywhere. And you see that the most susceptible crops, as shown in the picture, is groundnuts and maize, which are staple foods in most developing countries, especially Africa, where children are given complementary feeds made from maize, usually porridge made from maize. This is the global distribution of aflatoxin. We see that the most vulnerable continent is Africa and also some parts of Asia. The objective of this research exercise was to analyze the current literature to determine the relationship between stunting and dietary aflatoxin exposure in children. Actually, we see, I got to wonder because it's projected that even in 2020, the height for age Z-score in children would have only increased by 0.7 units in Africa. And despite several macro and micronutrient interventions that have been carried out in Africa, so I got to wonder, could it be actually the type of the food or what is the problem? That's why I actually chose this research exercise. So I aimed at trying to link if aflatoxin, which could be one of the toxins in the food, could actually have a role to play in this public health problem. So for the methods, relevant information was collected online from existing journals, articles, papers, and books, and under PubMed, Science Direct, and Google Scholar. The most cited articles were included and used to find other related articles. Then all the relevant material was included, and where possible, the most current literature was cited. These are some of the epidemiological studies that I came across. Most of them were carried out in Africa and Middle East, and most of them were cohort studies. They included children, lactating mothers, and pregnant mothers, where they checked aflatoxin levels in the umbilical cords. And in their findings, there was negative correlation between increase in both height and weight and aflatoxin albumin levels, such that the higher the aflatoxin albumin levels, the lower the height and weight of the children were. The mean aflatoxin albumin levels in children who were not breastfed was actually greater than in those who were breastfed. And the maternal levels of aflatoxin albumin in the umbilical cord had was a very strong determinant of height at a significant level of 0.04 and also weight at a significant level of 0.1. Furthermore, the height for age Z-score and weight for age Z-scores were significantly lower at levels that were less than 0.05 in infants who were born to mothers that had aflatoxin M1 in their breast milk. There was also an inverse association between aflatoxin albumin and insulin-like growth factors 1 and also insulin-like growth factor binding protein 3 at a significant level. For the animal studies that I came across, aflatoxin exposure, actually all the animal studies reported that aflatoxin exposure was significantly associated to weight reduction in animals. Then consumption of aflatoxin in feed decreased growth rate by 5% in broilers and 16% in swine. And in a study which involved rats, it was noted that in utero exposure to aflatoxin in rats led to reduced live births, delayed physical locomotors, and low mental development. So, to actually link the aflatoxin and stunting, this mechanism tries to explain actually what happens that could possibly lead to growth impairment. So, we see that when an infant is exposed to aflatoxin, may it be in utero, through breast milk, or through diet, the aflatoxin binds to DNA, inhibiting the synthesis of protein. And we see that the insulin-like growth factors are proteins in nature. So once we inhibit protein synthesis, we decrease the amount of circulatory insulin-like growth factors. And as Fiorenza mentioned in the morning, these insulin-like growth factors play a vital role in elongating the bone. Therefore, it could possibly lead to stunted growth. Furthermore, inhibition of protein synthesis also causes villus atrophy, and the villus atrophy, villus are the finger-like projections that increase surface area for absorption. So once they erode away, we see that the surface area for absorption of nutrients also decreases. And furthermore, the lactase that is found at the tips of villi is eroded away, and this leads to malabsorption of sugars and carbohydrates, including glucose and galactose, and therefore we see that there will be accumulation of water in the lumen, and this could probably lead to the inflammatory diarrhea, which in return leads to impaired nutrient intake, especially of micronutrients like zinc, which are vital for growth. Again, when protein synthesis is inhibited, we see that the regeneration of the gut, which actually is supposed to occur at a constant level, is reduced. Once we inhibit the intestinal regeneration and also the tight junction that regulate the permeability of the intestine is interfered with. Once the tight junctions are interfered with and we inhibit the regenerations of the intestine, there tend to be a reduction in intestinal barrier, and once there is reduced intestinal barrier, we see that there is infiltration of antigens and microbial products into the lumen, and this in turn actually activates almost the entire immune system, the pro-inflammatory and anti-inflammatory factors, and this will lead to systemic inflammatory response, which is associated with stunting. And to emphasize on the possible effects of aflatoxin on intestinal tight junctions, this illustration here, these are the normal tight junctions, but once a child is exposed to aflatoxin, we see that these tight junctions are interfered with and they become permeable, and therefore the microbes and other antigens are able to infiltrate into the bloodstream, causing inflammation, and also we have malabsorption of nutrients and food intolerances, and this also interferes with the bacterial distribution in the gut, and all these processes synergetically work out to possibly cause retarded growth in children. For immune suppression, we see that once protein synthesis is downregulated by aflatoxins, the mRNAs and that are responsible for the coding of the cytokines are also downregulated, and therefore we have a decrease in cytokine production. This in total leads to immune suppression. So it's noted that aflatoxin suppresses production of interleukin-6 and tumor necrotic factor alpha. It also reduces secretion of salivary SGM, which results to inflammation of the gut epithelium. Aflatoxin also decreases response to humoral antibodies to vaccines. So once a child is exposed, even if they are vaccinated, the vaccines are not as efficient as to a child who is not exposed to aflatoxins. Then, exposure to aflatoxin inhibits expression of insulin-like growth factor 1 and insulin-like growth factor binding protein 3, which are both significantly associated with linear growth in children. I've told you before about the insulin-like growth factors and the bone mass development. And this was actually echoed by an in vitro study which was carried out in Kenya in 2014. where the insulin-like growth factor gene and insulin-like growth factor protein levels were both downregulated after human hepatocytes were treated with aflatoxin B1. So, for possible solutions to these problems, we have 3 approaches, which include dietary approaches, good agricultural practices, and clinical approaches. To start with the dietary approaches, it's recommended that we can actually advocate for dietary shift from consumption of the vulnerable crops, which are actually staples in Africa, like maize and groundnuts, to shift to consumption of millet and sorghum, which are less susceptible to aflatoxin. But will people agree to shift what they're used to? So we have another option where we can use adsorbent materials like Navosil, in which that is the commercial name, which is actually calcium montmorillonite. This is a form of clay that binds aflatoxin, making its bioavailability in the lumen go down, and therefore the absorption rate is reduced. And also we can use chlorophyllin, which is an extract of chlorophyll, and it acts as a scavenger for the aflatoxin, therefore preventing the bind between aflatoxin and proteins. Therefore, it will prevent the downregulation of protein synthesis. Or we can use lactic acid bacteria, which binds to aflatoxin physically, making it unavailable for digestion. On the other hand, we can advocate for good agricultural practices, which are pre-harvest like use of transgenic crops. For example, there is a strain of maize which is resistant to insects. You know, insects are actually vectors of aflatoxins. When they bore holes to the kernels, they destroy the crop, making it vulnerable for the aflatoxin to grow, and they also actually carry the aflatoxin spores, and they act as vectors. Or we can use biocontrol, where we have a toxigenic group of aspergillus that can actually destroy the aspergillus that cause aflatoxin. Or we can also call for good cultivation practices like crop rotation, where they can, or proper use of irrigation and fertilizer. And on post-harvest, we can call for early harvesting, adequate sun drying, proper sanitation, especially in the storage zone, and insect control. For clinical approaches, it's suggested that hepatitis B vaccination can be used, but this does not directly help in stunting. It's good if we're aiming at reducing the aflatoxin-induced liver cancer, but not stunting. And if a person already suffers from hepatitis, even if you give them the hepatitis B vaccination, it won't help much. So this clinical approach is not good enough. To conclude this, studies should aim at determining the exact daily dosage of aflatoxin that is harmful. Poor communities in Sub-Saharan Africa should be taught simple, sustainable pre- and post-harvest strategies. Then children, pregnant and lactating mothers in this region should be encouraged to consume fermented porridge, because, and I will suggest that this fermented porridge should be probably made of millet instead of maize, and fermentation will increase the availability of lactic acid bacteria, which binds physically to aflatoxin, making it unavailable for absorption. Then breastfeeding is the best option as always. It should be advocated for, because children who are breastfed are less likely to be infected with aflatoxin as compared to those who are given complementary foods based on the vulnerable crops. Thank you.
Very interesting, Janerose. Okay, so now we are open for questions. Any? Yes.
Janerose, thank you for your wonderful presentation. My question to you is that how early harvesting of either maize or other crops prevent the attack of any fungus or aspergillus? And so will you explain in detail?
Early harvesting?
Yeah.
Okay. In most cases, for example, in Africa, we see that maize that is ready for harvesting is not harvested on time. Instead, they leave it in the farm for quite some time, and you see the rain will rain on it again, and this actually will make moisture available for growth of aflatoxin. So instead, when it will be better if the maize was ready for harvesting, if it will be collected immediately instead of leaving it out in the field where it's rained on again, increasing moisture content and then making it vulnerable to aflatoxin.
I thought before ripening, because if you harvest early, it will have higher moisture content. So.
No, it will be ripened already. Thank you.
Jen, thanks for your presentation. Aflatoxin and stunting, very interesting, yes. Mine, I think, is just more of a comment. At some point, you're saying people should now think of shifting from the maize and so forth to millet or something like that. But you know it very well, like in Kenya, you people are so much indented to, is it gideri, combination of beans and maize? I think what you should be advocating for here is better post-harvest handling of the maize or the granules for that case, just like you mentioned it, that when you harvest, you just make sure you follow good agricultural practices. Otherwise, if we start saying people should move from maize consumption maybe to millet or other things, it may be a little bit tricky for us.
Okay. Thank you, Francis, for that comment. Actually, it's better the way you put it for the post and pre-harvest solutions, and the dietary shift is just a suggestion. And even if they will not practice dietary shift, in case they don't observe the pre and post-harvest interventions, then this availability of Navosil, it could act as an emergency in case the aflatoxin is already there, maybe. Thank you.
Janos, I have a quick question. In Europe particularly, there's a lot of anti-genetically modified plants, or they think that that's going to ruin agriculture, ruin our health. And that's one of the things you suggested. What do you think about using genetically modified plants for things like protection against aflatoxins?
Okay. My take is that education is the best way out. If we could carry out tests and see that these crops will not harm the health of individuals, then we can actually educate the community and tell them the benefits of these crops, because it will actually help to prevent the spread of aflatoxin. So I think we should put out everything clearly. If there are any side effects, we let the community know. But if there are no side effects, then we can educate them to learn that. That's my take.
Yeah, my concern is about the last point which you talked about, breastfeeding and the aflatoxin. So are you trying to relate infant formula to aflatoxin exposure, and in case breastfeeding cannot be continuous, so it has to be for a specific time? What can we do to minimize aflatoxins in just immediately after breastfeeding?
Okay. In that study, what was observed was that children who were exclusively breastfed, had lower levels of aflatoxin albumin adducts compared to those children who were given mixed feeding of both breast milk and porridge made from maize. So it will be better to do exclusive breastfeeding to protect the child within the first 6 months. Then thereafter, it will be better to continue breastfeeding the baby. And maybe if you still want to use the maize to make the porridge for the baby, it will be better to introduce children to fermented products that may have lactic acid bacteria that can bind aflatoxin.
Very nice talk by Jane Rose. And we are now, I think we are finished. And now we are approaching to the end, and the real end. And this time Jessica will talk about time matters, aspects of biological clock, meal timing, metabolism, energy balance, and weight regulation. Okay, so.
Well, good afternoon, everybody. I know this has been a very long day and time is running. So I want to show you some pictures before I start my presentation. Maybe some of you are familiar with this, The Persistence of Memory from Salvador Dali. Then Clock River from Chagall. Why do I show you this? Because we're obsessed about time. In all these pictures, you can see some clocks, right? And then we're familiar with the Wall Street famous phrase, time is money. But I want to show you another thing, a set of silverware with a clock. Because I want to ask you a question that I want to keep you that I want you to keep in mind during this whole presentation. Do we think that the meal timing is detrimental for our health? So those of you who think they don't have time for healthy eating will sooner or later will have to find time for illness. So keep this in mind. My subject for this research exercise is time matters, aspects of meal timing, metabolism, energy, and weight regulation. It was supervised by the knowledgeable Professor Seharia Madar, and my name is Jessica Rosenstein. I'm from Mexico. During this presentation, we're going to cover the function of the biological clock and the circadian rhythms, the influence and relationship between meal timing and biological clocks, and the relevance of mealtime for successful weight loss strategies and obesity treatment. Okay, I'm going to give you some background and introduction. We know that globally, and more in the Western countries, we're facing a nutrition transition, passing from problems from undernutrition to problems of overnutrition, such as overweight and obesity that are leading to non-communicable diseases. Time and number of meals can vary based on our country, ethnicity, lifestyle, and many factors. In the modern society, it is very common to have an inadequate meal scheduling. Why? Because some of people have shift works, very important workloads, or simply by our own habits. Most of you should know we count with a biological clock. Maybe some of you don't know that we also count with peripheral clocks that are synchronized with this biological clock. We're going to cover this subject deeper during this presentation. I want to point out that mealtime and weight management are very related. And actually, mealtime can influence the outcomes. New approaches for overweight and obesity are needed because trends keep going up. So 65% of world's population live in countries where overweight and obesity kills more people than underweight. So it's something to keep in the mind. I want to show you this figure. This figure shows us the trends of overweight worldwide. The countries you see in red are countries where overweight reaches equal to above 60% of the population. This means 6 out of 10 people are overweight in these countries. 1.4 billion adults aged 20 and older are overweight. This trend is from 2008, and I don't think this picture has improved by this time. And globally, by 2008, around 35% of adults 20 and older were overweight. So this is very important to address this problem. Since we're going to talk about timing, I want to introduce you to this concept that humans have biological rhythms all along the day. And they are synchronized by the environment and by the nature. And the science that studies this is the chronobiology. To introduce more a little bit about the subject, I want to show you how our physiology varies. For example, at 8:30 in the morning, the intestinal peristalsis is very frequent. This can help us also to address problems, for example, of constipation by knowing this. Then at 10 in the morning is our greater period of alertness. This relates to the cortisol secretion that starts even before that. At 3 p.m., we have a drop in alertness because our cortisol level starts to go down. Then at 9 p.m., we have melatonin secretion, the beginning. Melatonin, as you know, it's the hormone that relates to the sleep time. And melatonin is also related to the dark cycle. So our body is getting ready to go to sleep. And then at 10:30, our intestinal peristalsis ceases. That means it's not the time to eat anymore. It's the time to rest, but not the time to digest. Then I want to show you some circadian rhythms of physiological variables. As you can see, okay, it's not working. Yes. It doesn't matter. Early in the day, we start with our peak of cortisol. Yes. Here we have our peak of cortisol at the very, very beginning of the day, because we need to be alert. We need our stress hormone to start our day. Then this keeps going down until it reaches the night. And then if we see, for example, the trend of the leptin. Leptin, as you know, comes from leptos, that it's lean. It's the hormone, the most important anorexigenic hormone that relates to satiety. It has its lowest point during the day because we need to renew our fuel. So we need to be hungry. And then during the night, it reaches normally the highest point because we want to be without hunger to have a good sleeping time. And then, as I told you before, melatonin secretion starts as night comes, and then it reaches its highest point. Well, who coordinates all the variability of timing? The responsible for this is the suprachiasmatic nucleus, that it's located in the hypothalamus in the brain. And usually, it's synchronized by the light. We're going to see this. For example, with the light goes through the retina by the retinohypothalamic tract, and it reaches the brain. And then, this, via the clock genes, will synchronize the 24-hour cycle. However, via hormonal and neuronal output, will coordinate and synchronize with peripheral clocks, which are located in peripheral tissues. We have peripheral clocks in very important metabolic organs, such as it is the case of the liver, also in the intestine, in the lungs, in the heart, in many tissues. But also, it's important to mention that we have a clock in the adipose tissue, because adipose tissue is responsible of the production of the adipokines, such as leptin, adiponectin, that help us to regulate our appetite. Besides light and dark cycles, because we saw that the main trigger for this synchronization is the light, feeding and fasting can influence, and also activity and rest can influence this circadian system organization. Here I'm going to show you how the core clock genes, the basic mechanism is that we have the clock and the BMAL transcription factor, which are the positive elements that will drive the translation of the clock genes and the efferent genes that control the rhythms. But at the same time, once enough clock genes are translated, they are going to translocate from the nucleus to produce the negative elements, which are 3 periods and 2 cryptochromes. But we're going to see this deeply here. We have here the BMAL and the clock transcription factors in the cytoplasm, which dimerize together and enter to the E box of the promoter side of the period family and cryptochrome family, which are gonna, once enough of these are translated, then they will translocate again to the cytoplasm and repress the activity of these transcription factors. However, we have 2 other reinforcing, 1 negative and 1 positive loop. The retinoic acid orphan receptor will also translate to the via the response element and will translate to the BMAL1 gene as a positive loop. And the reverse erythroblastosis viral alpha will be a repressor factor. Then I want to show you, I want to link this circadian clock with the food. So we have 3 scenarios. 1, the regulation of when we eat food ad libitum, that means uncontrolled without a schedule, then light synchronizes the suprachiasmatic nuclei, which in turn drives the activity, the hormones, and the neurons, via neuronal and endocrine pathways, and then will synchronize also behavior, activity, and the feeding time. In the second scenario, when we restrict food, but only in timing, not caloric restriction, which is called restricted feeding, light will remain the dominant synchronizer of the suprachiasmatic nuclei, which is the master clock. However, peripheral clocks will be synchronized with the feeding time. And in the third scenario, when we have temporal and calorie restriction, which is called caloric restriction, both the master clock and the peripheral clocks will be synchronized by the food cues. That means by our feeding time. So then on this relies the importance of keeping adequate meal schedule. As you see, it's very related. Then we can get to this concept of food entrainable oscillator, which in simple terms would be a clock driven by food, which is not located in the suprachiasmatic nuclei. Still, it is not well known where it is located. They think it's located in an area of the hypothalamus, the dorsomedial part, that it's also related to satiety hormones and hunger hormones. However, this food entrainable oscillator, this clock, will drive the food anticipatory activity. This was discovered by, for example, they took mice and they ablactate them from the suprachiasmatic nuclei, but they saw that even without this element, they still had the food anticipatory activity. What is the food anticipatory activity? It's an episode in advance to food. 2 or 4 hours before our body starts getting ready to be fed. So body temperature increases, serum cortisol, amino acid, glucose, and liver enzymes. So this was an important discovery. So then we can see that by scheduled feeding, we can improve our health markers. And also, with an inadequate schedule, we can disrupt our circadian rhythms. Here, I'm going to show you more on detail, well, a little bit more graphic, the food entrainable oscillator. As you can see, we have food here, which will drive the activity of the intestine, the clock of the intestine via the digestion and absorption, and also the liver, which is involved in this metabolism, and the pancreas. So this will sign to the hypothalamus besides the suprachiasmatic nuclei and will drive the food anticipatory activity. Then what happens if we have some kind of desynchronization? We can cause a chronodisruption where our rhythms just lose the normal pace. Disturbance of the temporal internal order of physiological and behavioral circadian rhythms, it's what we call chronodisruption. But also it is the breakdown of the normal phase relationship between the internal 24-hour environmental cycles. This can be caused by very common nowadays lifestyles, such as people that do shift work, night eating, sleep deprivation, and night exposure to light, computers, iPhones, whatever. And all of them make people more prone to obesity. So it's important to take this into account. So which are the induction, in general, which are the induction factors for the chronodisruption? First of all, the impairment of the inputs of the circadian pacemaker, such as continuous light, frequent snacks, nocturnal feeding, or nocturnal exercise. Definitely, the night, it's not the right timing to do exercise. Then it can be an uncoupling between oscillators in the suprachiasmatic nuclei. This can be caused by aging, where our clock genes don't work the same way. And also outputs, which could be, for example, hormonal suppression, like for example, hormonal suppression of nocturnal melatonin or the loss of cortisol rhythm. All of them will be chronodisruptors. And in this picture, I'm not going to go into detail, but I want you to see how an unusual feeding time can cause a very, very important side effects to our body. First of all, it will cause a chronodisruption. Then we will have changes in our adipose tissue, and therefore leptin, adiponectin secretion, organs in digestion also, because they also synthesize and secrete enzymes. Then we know that food components, lipid, amino acid, glucose, will feed back to our brain in a certain way, so this will influence. And I want to point out specifically that genetic background is important, because nowadays we know that we can have a chronotype. We can be morning people or evening people. However, we can still change this via single nucleotide polymorphism, epigenetics. So by having disrupted feeding schedules, we can also disrupt our genetic. Okay, for relevance of timing for overweight and obesity treatment, I want to show you, first of all, this study. In this study, they compare a high caloric intake at breakfast and at dinner. They had exactly 2 groups of overweight and obese women with exactly the same diet, an isocaloric diet of 1,400 calories. And the only thing that changed is that in the breakfast group, the highest energy accounted for breakfast, for sure. Then for lunch, they had 500 calories, and dinner was very light, 200 calories. And for the dinner group, it was only backwards. The 700 calories were at dinner. However, lunch remained exactly the same, and as I told you, calories were the same. Here in the results, this study went for 12 weeks. We can see that the breakfast group compared to the dinner group had greater changes and better results in terms of anthropometric measurements and also other serum, lipid profiles and glucose, insulin, ghrelin. In everything, breakfast group improved. And especially I want to point out that in terms of triglycerides, the breakfast group had a decrease of 33%. However, the dinner group had an increase. This is related to if we have fat in the night or an important amount of calories in the night, triglycerides will easily go up. Then here we can see that as long as the study went, the gap between those groups became wider. Then I want to show you this second study, which was conducted in Spain. In Spain, the main meal time is lunch, so they wanted to evaluate the having lunch early versus having lunch late, before 3 or after 3. And they measure also other parameters, such as clock genotype, appetite hormones, energy intake and expenditure, sleep duration, and chronotype. Same for as the study before, the people included were overweight or obese. However, the study went for 20 weeks, not for only 12 weeks. And same, we have a significant difference between the early eaters and the late eaters, and the early eaters have better outcomes in terms of weight loss as compared to the late lunch eaters. So, and here the trends go exactly the same as the study we saw before. As long as the study went, the more weeks they followed this regime, the gap between both groups became wider. So it doesn't only matter what, it matters when. And finally, I want to show you this study with animals. You can see a lean mouse and a fat mouse. This is, I want to show you this very simply. Here, this mouse is following a regular eating schedule, breakfast at 7, lunch at 12, dinner at 7. However, this mouse follow a very, very long fasting, and late night food intake impact changes in the peripheral clock phase, promoting irregular feedings. And besides that, having longer fasting periods is not good to keep an adequate meal schedule. So in conclusion, there is an increasing evidence of the influence of the circadian clock on human physiology in our feeding behavior, metabolism, physiological endocrine activity, sleep-wake cycles. And also, we know that disrupted biological rhythms impact the circadian rhythms, leading to hyperphagia, weight gain, obesity, and moderate to severe chronic conditions such as metabolic syndrome, obesity, but moreover to severe conditions such as cancer, and in general to less life expectancy. The importance of the relationship between feeding and biological clock relies in the fact that food and feeding time have the ability of reset our rhythms. Adequate rhythms means adequate functions and then well-being. Timing distribution should be incorporated in weight loss strategies. That's what I think. However, there's still a lot of room for investigation and research because most of the research has been performed in animals. So it's a good perspective to see and to take into account. So thank you very much.
Jessica, so we are on time, and we are going to ask about timing.
Thank you. Well, first of all, congratulations. It was a very, very nice talk, interesting, avant-garde topic, and it was such a massive attack of information. I have so many questions. but I think I'm just gonna focus to one, and I would like to have a specific example of a micronutrient that can be beneficiary to take it, I don't know, like when, like a macronutrient, a specific hour that you recommend me.
Okay, well, I can think about carbohydrates. For example, we know that insulin sensitivity, it's better during the day, during the morning time. So, because actually we know that after the afternoon, we start to have what it's called afternoon diabetes, where our insulin, it's not as efficient as it should be. So if I can give one piece of advice is not to leave the big charge of carbohydrates at night.
So the myth about not eating fruit at night, it has something of truth.
It depends on the quantities, because also they have seen that it all relates also to the amount. So I would think that if you have an apple as a dessert in the night, because we usually have this sweet taste that we want to have, it's better than to have an apple pie. So it's okay to have fruit at night.
Okay, thank you.
Jessica, I don't want to confuse you with your mentor, but you know that Professor Madar has done some work with weight loss, and they gave all the carbohydrates in the evening, and they were much more successful in their weight loss diets.
Yes, actually, I know, I'm familiar with that.
So how does that coincide with what you just told us, that maybe we shouldn't be eating carbohydrates in the evening?
Think it depends. I think it depends. This study was performed with police officers here in Israel, and actually most of them were overweight, and what they wanted is to improve it was very interesting because they wanted to improve also their stickness to the regime. So by giving the carbohydrates at night, they modify the secretion of leptin and adiponectin, and this helped them to avoid the sensation of hunger, and they felt more satisfied. So actually, I think it's okay to give the carbohydrates at night. However, I don't think it's okay to eat in what it's not our normal period of activity. I was just suggesting Sarah that normally this is the case, but in terms of overweight, I think it's a good strategy to modify the hormone secretion.
We have an internet question, so let's pass this over to Marie.
Okay. Well, first of all, before I ask the question to Jessica, I have a comment from Kenya. We have a viewer from Kenya, and she wanted me to, she said, Catherine Sarang from Kenya, she said, good presentation on aflatoxin exposure and stunting from Janerose. Okay, now Prabhat has a question for Jessica. It is now accepted that adipose tissue at different depots have their own depot-specific function and metabolism. Is there any differential circadian regulation of adipose tissues at different depots?
Like abdominal or on your
hip
subcutaneous, and these are adipose tissue.
Good question.
It's an excellent question. I don't think I have the expertise to answer this question. However, I would think that the clock of the adipose tissue will differ from the visceral and the subcutaneous fat. And also, it's important to address that those fats can be very different in terms of our eating habits. For example, people in Spain that have a diet very rich in oleic acids and they're overweight, they have a very different fat storage than people in the United States that eat a diet full with saturated fats. It's not exactly the same fat. However, even though both can be in the same overweight, fat, it's different. So I would say it has different secretion. But anyway, I would need to research more.
Professor Madar will be
One moment, Professor.
You need the microphone.
Until now, we don't have any information regarding the, specific clock in different adipose tissue. Although now we know that they are respond differently. That's for sure.
Sorry, do you have
But
any questions
yes, I do. I do have a question. You told us that leptin secretion is actually different between night and in the morning, okay? What's the level of the secretion of leptin in the morning? You have shown that.
Go back to your slide.
In the morning, usually.
I know that during the morning, it's the lowest point of secretion, between 10 in the morning and 4 p.m.
Let me go ahead now. In the morning, that's the low level, right?
Yes.
And at night?
No, at night it increases.
Its levels. Okay, that's the typical pattern of leptin secretion, right? Now,
Yes.
if you would like somebody to lose weight, what you would like him to reduce? What the level of leptin will be in the morning, at night, and at night? If we would like somebody to lose weight.
I think that relates with your study because you knew that as long as these people will be awakened and they don't stick to diet patterns, you want to keep the leptin in higher levels to improve in the morning, which is the activity time, because you want them to stick to the diet pattern, and maybe at night they will be so tired and very dark that will induce melatonin, so they will be very happy to
give them some,
be hungry.
Maybe you have to give them some diet that will not increase. It will increase the level of leptin during the day.
Yes.
And the night will be low, so they will feel satiety during the day. They will not grab food from the refrigerator. And the night they go to sleep. They will keep their diet.
Yes, for sure. I think it depends on the chronotype, and it depends on what we want to address. If we're normal weight, then I think the leptin should keep the normal cycle. However, I think it's an excellent strategy to make people adherence to a diet, like an hypocaloric diet, because this way they will not have the cravings, and this will have good benefits.
Hi. Congratulations for your presentation. It was very interesting. So you were mentioning about a shift work that it was related to this chrono disruption. What about, I was thinking about some people that have work that interfere with these chrono disruptions, such as people that work in airlines and are traveling during these hours, like strange hours.
Excellent question. Well, actually, these things have been addressed in a lot of studies, and they have seen that female, for example, female workers that work in airlines as tripulants, which, for example, do transatlantic flights, and they cannot keep adequate, like, 24-hour cycles, can have very important chronodisruption problems, and actually their menstrual cycle can actually stop for complete, because since you know that in the hypothalamus we have the axis for the sexual glands and everything, and it's everything is related. So actually it's very detrimental for their health, and mostly for their reproductive health.
I'm trying to see if my question is asking the same thing. I think it's different. All right, so combining what you've taught us, as well as actually some things that Oren Freud taught us, he mentioned that given what you said about the studies with its time restriction as well as caloric restriction, he gave an example, like the prime example of being like a 6-hour period of time that you eat before and it's fasting otherwise. That being the optimal way to set a biological clock. Now, we also mentioned sun exposure or light exposure. How much of an influence does that have, assuming you are completely, like every day accurate on the caloric restriction and the time restriction? So like, that's all good, you're doing all that perfectly, but it's later. Like, let's say you start eating at 3 o'clock and finish at 9 or 10 when it's dark out. So do you think the light...
but do you keep the same schedule?
Yeah, you keep everything, but the light exposure is going to be different than, I guess, what a normal biological clock would be.
Well, then, if you have a temporal and hypocaloric restriction, the light will not be the main trigger to the suprachiasmatic nucleus, to the master clock. As I showed you, it was the third scenario. It was the food cues that actually regulate both the suprachiasmatic nucleus and the peripheral clocks.
Right, okay, so food intake being the most important factor in the regulation.
If it is hypocaloric and temporal restriction,
both.
Both.
Okay, thank you.
I requested to ask this question when I'm off the internet. I don't want to...
Oh, afterwards, okay.
Okay. No, I want to ask to get an answer, but not when I'm connected to the...
I think I have another question.
So you talked about on the first side about the cardiac rhythms.
Circadian.
If I don't know if you can help me to go about the first slide.
Do you want me to go back?
Yeah. Then you also talked about these people who are like
this one,
yeah.
Or the next one?
The cycle. That one.
This one?
Yes. The people are working in flights and there are disruption in the hormonal levels and whatever. So when I look at that, the cycle, it shows that around the 6 p.m., 7 p.m., and the 5 p.m., that is time for like high blood pressure, weighted muscle strength, and high body temperature. So like if we need that to sex, are you trying to say that that time is also good for, how can you do that to sex?
To sex?
Yeah.
To have intercourse, or what do you mean?
So the cycle towards sex.
Actually, it is an excellent question. I don't know about the libido relationship with this, but if I can imagine a scenario, then I could say that it could be excellent timing, because if the blood pressure is good, maybe for the man it's an excellent timing for an erection.
Talking about timing, you have plenty of time at night. Oh my God. Fertility 101.
So it's a good question, really.
Yes.
Because, that something can happen.
So are you speaking to the microphone?
About fertility.
Yes, you must speak into the microphone.
The people at home can hear you.
Joseph. He didn't want that. What did you say?
No.
Okay, Jessica, thank you. Very interesting topic, really. So can you tell me anything about the clock of micronutrients and not macronutrients?
Yes, well, there are some reviews that have seen that, for example, well, not exactly micronutrients, but other food things such as ethanol or caffeine can influence our biological clock. And also, I would say that this can relate on the absorption of the vitamins. For example, I could say that maybe liposoluble vitamins could be better to be taken in the morning, where we can metabolize easily the fats, and then, but there is not a lot of research in regards to a specific micronutrient, but in my point of view, this could be an answer.
Just regarding your question, no, really, there is a variable expression in testosterone during the day and the light. So if you expose people to light and dark, you will see a difference in the in the rhythm of the testosterone secretion. So it's my thing. So satisfies.
Jessica, I know you did mention some bits about future research, but if you could think of the next step, maybe in terms of your interest, what do you think should be the next thing explored or tested clinically?
Well, I think
she's planning to have a master in this.
I'm going to do my PhD, and then I'm going to discuss the results. Well, I think actually they already start with this, because a lot of people have started with the term of chrononutrition. However, I don't think there is still enough research done, because maybe a lot of people have published books, but I don't think they have the scientific evidence to support these ideas. So I think this goes this way, like also nutrigenetics, nutrigenomics, and chrononutrition.
Nutrition, it's difficult, we know.
Yes.
For sure.
And epigenetics.
Exactly. Thank you very much.
Okay. So we are now finishing our last session, and we are very, very happy and satisfied with your lectures, with your presentation. I think you did a great job, and we feel like mothers that their children did so well. Okay.
Okay. For the last word, first of all, it was a wonderful 2 days. And we want to once again thank the PEARS Foundation for making this possible. I saw that lots of people were watching through the internet, which was very encouraging, from all over the world. And I know that some people got up in the middle of the night to see some of our presentations. So it was a wonderful webinar with a lot of participation. And it's just the vision of the PEARS Foundation that allows us to do these things and do it internationally. And we once again want to thank them for sponsoring so many of our programs. So have a wonderful, everyone here in nutritional sciences, this is actually, if you're doing a one-year degree, this is really your last academic activity. And for those of you that are continuing on for a second year of research, we wish everybody good luck in their second year, but all your classroom and academic activities in this campus, research maybe will continue, but your classwork is finished and finished very successfully. So everyone should feel very good, and Betty and I will be happy to give very good grades on your projects. So thank you all very much.
Thank you. And thank you to all the teachers and to all the people who help us to do this, all the mentors that were indeed very, very good. Okay, thank you.